The main features of the sella turcica are this deep depression, the pituitary fossa for the pituitary gland, this shallow groove for the two optic nerves, and these four projections, the anterior and posterior clinoid processes. This sloping surface behind the posterior clinoid processes, the dorsum celli, is continuous with the base of the occiput. The floor of the middle cranial fossa is marked by numerous openings for nerves and blood vessels, which we'll come back to later in this section. Now that we've looked at the shape of the facial skeleton and the parts of the cranium that it's attached to, let's look at the individual facial bones and see how each of them contributes to the features that we've seen. We'll look at the 5 largest facial bones first. There are the frontal and zygomatic bones, the maxilla, the sphenoid bone, and the ethmoid bone. The frontal bone is a very large bone. The lower part of the frontal bone forms the beginning of the root of the nose, the upper part of the orbital margin, a small part of the temporal fossa, and a large part of the roof of the orbit. The frontal bone also forms most of the floor of the anterior cranial fossa. The part of the frontal bone near the midline is hollow. The hollow space is the frontal sinus, one of the paranasal sinuses, which we'll look at shortly. Next, we'll look at the zygomatic bone. The zygomatic bone forms the bony prominence of the cheek. It also forms the lower lateral part of the orbital margin and this part of the lateral orbital wall. The zygomatic bone extends backward to meet the zygomatic process of the temporal bone, forming the zygomatic arch. Now we'll move forward and look at the maxilla. Here's the maxilla. The right and left maxillae are joined together in the midline. On each side, the maxilla forms the lower medial part of the orbital margin and almost all of the floor of the orbit. The maxilla bears the upper teeth. On the underside, it forms much of the hard palate. The maxilla is hollow. It contains the largest of the paranasal sinuses, the maxillary sinus. To see the posterior part of the maxilla, we'll remove the zygomatic arch. Here's the back of the hollow part of the maxilla. Down here, the maxilla is joined to the bone behind it, the sphenoid bone. Apart from this attachment, the maxilla is separated from the sphenoid by this impressive cleft, which has a vertical part and a horizontal part. The vertical part of the cleft is called the pterygomaxillary fissure. The horizontal part of the cleft is called the inferior orbital fissure. The inferior orbital fissure, here it is from in front, separates the floor of the orbit, formed by the maxilla, from the lateral wall that's formed by the sphenoid. Now we'll move on to look at the sphenoid bone. The sphenoid bone is extremely complex. It extends all the way from one side of the skull to the other. The sphenoid bone forms important parts of the underside and outside of the skull, and it forms part of the orbit. The sphenoid bone also forms this large and complicated part of the floor of the cranium. Here's a sphenoid bone all by itself. The sphenoid bone has a central part, and on each side 3 major projections: the lesser wing, the greater wing, and the pterygoid process. The central part of the sphenoid includes the clinoid processes and the pituitary fossa. The central part of the sphenoid bone is hollow as we'll see. The lesser wing, which is the highest part of the sphenoid bone, forms the sphenoid ridge, which separates the anterior and middle cranial fossae. The underside of the lesser wing forms this small but important part of the back of the orbit. The greater wing of the sphenoid forms the front wall and part of the floor of the middle cranial fossa. On the outside, the greater wing forms this part of the temporal and infratemporal fossae, and it also forms this large part of the lateral wall of the orbit. The greater wing and the lesser wing are joined here, but more medially they're separated by this triangular gap, the superior orbital fissure, which forms a large opening between the orbit and the inside of the cranium. Here's the superior orbital fissure from the inside. We'll get a better look at it in a minute. The pterygoid process of the sphenoid bone projects downward behind the maxilla. The pterygoid process includes the lateral and medial pterygoid plates, which are the attachments for some important muscles that we'll see later. This hollow between the pterygoid plates is the pterygoid fossa. This little hook is the pterygoid hamulus. It's a pulley, as we'll see later. The last bone on our list of large facial bones is another quite complicated bone, the ethmoid. The ethmoid bone is a little hard to understand at first because in the intact skull, most of it is hidden from view. The only parts of the ethmoid bone that we can readily see are this small part of the floor of the anterior cranial fossa, the two cribriform plates with the crista galli in between, and this part in the medial wall of each orbit. It'll be easier to understand the ethmoid bone when we look at the nasal cavity in the next section. Till then, we'll leave the ethmoid bone alone. There are three smaller facial bones that we'll look at briefly: the nasal, lacrimal, and palatine bones. This is the nasal bone. This is the lacrimal bone. The two thin nasal bones form just the upper part of the bridge of the nose. The structural supports for the projecting parts of the nose are made of cartilage, as we'll see later. The little lacrimal bone forms the most medial part of the inferior orbital margin. This opening between the lacrimal bone and the ethmoid bone is for the nasolacrimal duct, which takes tears from the corner of the eye to the nasal cavity. Last of all, we'll look at the palatine bone. Here's the lower part of it. On each side, the palatine bone forms the posterior part of the hard palate and part of the side wall of the nasal cavity. We'll get a better look at the palatine bone when we look at the nasal cavity. Now we'll move on to take a look at the openings in the floor of the anterior and middle cranial fossa that we saw earlier. We'll look at three openings that pass forwards, two openings that pass downwards, and one that, in spite of appearances, passes obliquely backwards. We'll start with the ones that pass forwards. This round opening just in front of the anterior clinoid process is the optic canal for the optic nerve. Lateral to it, this large triangular opening is the superior orbital fissure, which we've seen already. Numerous nerves and blood vessels pass through it into the orbit. Below and behind the medial end of the superior orbital fissure, this smaller round opening, the foramen rotundum, is for the maxillary branch of the trigeminal nerve. We'll put this pointer in the foramen rotundum and go round to the outside. Here's the superior orbital fissure again. Here, medial to it, is the optic canal.